This is WhyItTV.
And here we take a stack of source material articles, internal documents, research papers, and we use it to explore the systems, the incentives, and the constraints that dictate how major brands and ideas actually function.
Yeah, we're really trying to go beneath the outcomes to understand the infrastructure.
Exactly.
And in this deep dive, we're slowing it down, peeling back the layers on one of the most familiar objects in the world. We want to look at how it operates as a really complex engineered system.
And that system today is Lego.
Right.
It's so deceptively simple, isn't it? I mean, you think Lego, you picture plastic bricks, bright colors.
Familiar shapes, yeah.
Maybe that faint smell of old plastic from a bucket in the attic. But the sources we've pulled together, and we're talking about everything from engineering specs to crisis management reports, they reveal that Lego runs one of the most complex, precise, and highly constrained manufacturing systems in all of modern consumer goods.
Okay, so let's unpack this then. Our mission today isn't really to talk about nostalgia or even how fun it is.
We are looking at Lego not just as a toy company, but as this massive, meticulously engineered infrastructure for play. And we really need to explore the enormous and frankly sort of terrifying pressures that this idea of continuity and precision place on the business.
It's everything. These pressures range from manufacturing tolerances thinner than a human hair, all the way to governance structures that are designed to survive generations of ownership.
So if you stop someone on the street and ask them, what makes a Lego brick great?
Right.
The answers are usually about creativity, imagination, nostalgia. But if you talk to an engineer, the real sort of structural genius is in something way less romantic.
Absolute unwavering precision manufacturing.
Exactly.
That is the core claim supported by all the source material. Lego runs a manufacturing system that demands a quality you'd usually find in, like aerospace or medical device production.
But for a kid's toy.
But applied to a child's toy. And the numbers on consistency, when you actually put them into context, they're genuinely hard to process.
Okay, so give us the hard stats. What defines this system?
The standard they hold themselves to is just staggering. Out of every single million tiny bricks they produce globally across all factories, only about 18 bricks are allowed to fall out of tolerance.
18 out of a million.
18. That is a failure rate of 0.0000002%.
Wow.
And you have to think about the physical scale here. This is a company that makes over 25 billion bricks every single year.
That's a huge number.
And if you look at the total bricks in circulation since 1958, some estimates put that number closer to 1 trillion. And every single one of those trillion pieces has to seamlessly connect with every other piece.
It's genuinely wild to think about that, NASA-level consistency being applied to a children's toy. I mean, does that kind of engineering commitment mean there's a massive ongoing cost burden that most companies would just never accept?
It absolutely does. You don't get this level of precision cheaply or easily. We're talking about the machines themselves, the injection molds, which have to maintain tolerances as tight as 0.01 millimeters to 0.05 millimeters.
Okay, put that in perspective for me.
The average human hair is roughly 0.07 millimeters thick.
So these tolerances are thinner than a hair.
Thinner than a hair.
And the technical difficulty there must be immense, especially given the material. This isn't military-grade steel, right? We're talking about plastic.
Specifically ABS plastic, which is prone to microscopic shrinkage as it cools.
Of course.
And that's precisely where the cost lies. ABS plastic is durable, it's resistant to chemicals, it has the right density, but to get that 0.01 millimeter tolerance, you need molds that are basically works of art.
Okay.
They're precision engineered, often from specialized steel, and they can cost millions of dollars each.
Yeah.
And on top of that, those molds have to be constantly maintained, cleaned, replaced with just extreme care to prevent anywhere that would compromise that consistency.
So the plastic is cheap, but the tooling is the massive investment.
The material is relatively cheap. The tooling to work it to that standard is the huge investment.
And all this attention to microscopic detail, it isn't just about making the product look nice, it's entirely structural.
Without that precision, the entire system just collapses. The sources define this as the necessary clutch power.
Clutch power, right.
That specific tolerance, not too loose, not too tight, is what determines the force you need to make the bricks fit firmly, but still allow them to be pulled apart by hand.
By a kid's hand, even.
Exactly. If the tolerance widens by just a fraction, the structure you build falls down. If it shrinks, you can't get the pieces apart, and the whole play experience is ruined. The structural integrity of the entire Lego universe is held together by this microscopic uniformity.
And that need for uniformity brings us to the biggest strategic constraint that really defines the company.
Backward compatibility.
Yeah.
This is maybe the most fascinating piece of strategic analysis in our source material, because it's marketed as a consumer feature, a bonus, a benefit, but internally it is a rigid, binding constraint. It limits the possibilities for everyone, from the engineers to the strategists.
So is it fair to say that backward compatibility is like a kind of engineering debt they voluntarily took on 65 years ago? And it forces them to always choose the most expensive, most difficult path forward.
That is an excellent way to frame it. It is a debt they willingly took on for the huge long-term payoff of customer trust. The fundamental rule, the contract with the consumer, is that every brick must fit with every other brick ever made.
Old bricks, new bricks.
Bricks made in Mexico, bricks made in China, bricks that have been subjected to heat, stress, repeated use by multiple generations. All of them.
And the moment they break that rule, they shatter the entire premise of the system.
They do. Just imagine they wanted to experiment with a new material, a cheaper, more sustainable, maybe slightly flexible polymer.
Okay.
Even if that new material was 99% close to the original ABS, but it expanded just a 0.02 millimeters more in the heat, it risks breaking that core promise.
Yeah.
And that commitment severely limits their materials experimentation, which we'll definitely get into later with sustainability.
Right.
It also restricts shape innovation, because every new piece has to obey the old geometry. And it completely rules out any manufacturing shortcuts that might save money but compromise that microscopic tolerance.
It's the ultimate lock-in strategy, but the lock-in isn't software or some digital platform. It's physical, measurable reality.
And that physical reality dictates their whole strategic approach. Most toy companies, they refresh their product lines by just replacing them. They launch a new generation with incompatible parts, forcing new purchases.
But Lego is different.
By sharp contrast, Lego refreshes by layering. They add enormous complexity over time, introducing thousands of new specialized elements. But the base system, that original 2x4 brick, remains the governing constraint, the absolute foundation.
That constant layering, though, adding new complexities onto an already complex base, that has to create massive operational complexity over the decades. I mean, even if it generates goodwill with customers, it just feels like a strategic headache waiting to happen.
It is the definition of a strategic headache. But the payoff, as you said, is immense. That strict adherence to the binding constraint created this deep intergenerational trust.
Yeah.
That when you walk into a store and buy the newest, most high-tech set, it will integrate perfectly with that dusty bucket of bricks you inherited from your parents.
Yeah.
They built trust by refusing to compromise on a single tiny dimension.
And that trust was critical because despite all the engineering genius and the precision we just talked about, that layered, complex infrastructure nearly collapsed about 2 decades ago.
It did.
The sources paint a really stark picture of just operational complexity overwhelming the organization, leading to a massive financial crisis.
The early 2000s were a genuine near-death experience.
Yeah.
The then head of strategic development, Jürgen Vignodstorp, he famously called it the burning platform. The very scale and success of the company had led to managerial myopia and just operational disaster.
That phrase, burning platform, that is a stark assessment. How bad were the financials in 2003?
Catastrophic. The company was losing money at an alarming rate. They had a negative cash flow of 1 billion Danish kroner. That's roughly 160 million US dollars at the time.
Wow.
Their total debt reached a staggering 5 billion kroner, or about $800 million. I mean, they were dangerously close to defaulting on their loans. The threat of a breakup or a fire sale was very, very real.
So what were the key management mistakes that led a company built on such fundamental quality and precision to that point?
The core mistake was a fatal loss of focus, and it was driven by over-diversification. They were just chasing too many trends.
Right.
Nudstorp later analyzed this, and he noted that any major undertaking, what he called an adjacency to the core construction business, should be attempted maybe once every 3 to 5 years.
Okay, that sounds reasonable.
Instead, they were trying to launch 3 to 5 of these major adjacencies every single year.
That sounds like strategic scattershot. I mean, they just stretched their resources, technical, financial, managerial, so thin, trying to be everything to everyone outside of their core system.
Exactly that. They were chasing the next big thing in media and licensing, and they failed to realize their core strength was the physical system itself. We can point to several specific failures. They launched themes like Galador,
Oh, I remember that.
a line of action figures that were mostly incompatible with standard Lego bricks, basically abandoned the very binding constraint we just talked about.
Unbelievable.
And they also tried non-core products like a Lego fashion line, Lego Wear, and these really complex, costly electronic initiatives.
And that reliance on electronics, that brought its own specific financial failures, didn't it?
It did. They suffered from severe pricing failures on these high-tech products. Internal reviews found this incredible operational blind spot. They were selling electronic sets with motors and complex components for less than what it cost to make them.
How is that even possible?
They just lacked the internal financial systems to accurately track profitability by individual product. So they were literally losing money every time one of these expensive sets left the warehouse.
That level of mismanagement just suggests an IT system that was designed for an earlier, simply era. It couldn't handle the new complexity.
That's a key insight. The old siloed IP systems were designed to track physical inventory and parts for the core sets. They were totally inadequate for tracking complex, high variable cost electronics or for forecasting demand on these volatile, movie-driven themes.
Right.
This led to massive cycles of over and under production, ballooning inventory, costly write-offs. And then, when the movie tie-ins like the early Star Wars and Harry Potter sets lost their initial blockbuster momentum in 2003,
Sales just cratered.
they declined rapidly, and Lego was left with warehouses full of specialized, theme-specific stock they couldn't sell.
So the solution had to be drastic. And it involved this deliberate return to the first principle.
Back to the brick.
Back to the brick.
The turnaround, which officially began around 2004 under Knudstorp, was an aggressive, multi-pronged effort. It focused fiercely on cost-cutting, a rigorous return to the core construction product, the classic quality sets that obeyed the compatibility constraint, and a more strategic, more disciplined expansion of licensing.
Which we'll get to. But this successful correction, it's intrinsically linked to a really critical governance factor. Unlike almost all global brands of this size, Lego is not publicly traded.
That private family ownership is absolutely fundamental to their structure and their recovery. The company is 75% owned by Kirk BDA and 25% by the Lego Foundation, both controlled by the Kirk Christensen family. And that structure insulated them from the short-term panic of public shareholders during the crisis.
And what does that family business mindset let them do that a public company beholden to quarterly earnings just might struggle with?
It just fundamentally shifts the incentive structure from optimization to longevity. Instead of having to justify every decision based on maximizing quarterly returns, they can evaluate decisions over decades, generations even. This allowed the family to focus on purpose beyond immediate profits, to take a genuinely long-term view, especially when it came to reinvesting billions back into maintaining that microscopic precision we talked about, and to stick with a painful, years-long turnaround plan without that external pressure to just sell off profitable segments to make the numbers look good for a quarter.
So the Knudstorp turnaround from 2004 to 2016, it was really about imposing discipline back onto this sprawling, disorganized system. How did they actually drive that massive cultural change internally?
Through radical transparency and system discipline. Knudstorp introduced management techniques like visual factories.
What does that mean?
It meant making key performance metrics, inventory levels, efficiency rates, cost per product, immediately visible and understandable right there on factory floors and in offices worldwide. The goal was to eliminate the blind spots that allowed unprofitable products to be sold below cost.
So if a team was designing a complex electronic kit, they could visually track in real time how their design choices were impacting the final manufacturing cost.
Precisely. It forced internal correction and accountability. He also fostered transparent communication, writing a weekly letter to all 500 middle managers globally.
Wow.
This constant dialogue about what was working and what wasn't, it reflected the family's long-term commitment and forced the managerial layers to buy into the change, not just accept top-down mandates. They rationalized the product line, reducing the number of unique elements by thousands to cut complexity and cost.
So today, the system manages that refocused, but still a layered product line at a staggering scale. If they're managing thousands of unique elements, tens of thousands of individual sets, how do they physically manage that global supply chain?
The scale is monumental. The system today manages a portfolio of over 840 products in 2024, nearly half of which were new launches, all drawing from that vast library of elements. To handle this, they abandoned their old centralized model and built a highly regionalized infrastructure.
And what does that regionalization look like geographically?
Lego now operates 5 primary factories, and 4 regional distribution centers, all strategically located close to their major markets. We're talking about facilities in Mexico, Hungary, China, the Czech Republic,
Okay.
with massive new factories or expansions under construction in Vietnam and the U.S. And this regional design is crucial for 2 reasons: speed and sustainability. It lets them respond quickly to shifts in regional demand, and importantly, it limits the environmental impact of shipping heavy plastic all over the world.
So it's clear the physical system, the factory floor, the distribution, those microscopic tolerances, is world-class. It's built on a legacy of long-term investment. But to manage that complexity and scale, the source materials confirm that the tactile physical play has to be underpinned by an invisible, massive digital infrastructure.
Absolutely. The survival of Lego as a modern global corporation depended on them realizing they couldn't just be a plastic molding company anymore.
Right.
They had to become a software-driven organization simply to manage this inherent physical complexity.
We're talking about colossal behind-the-scenes investment in IT infrastructure, a sector that's completely foreign to their traditional manufacturing culture.
That's right. And following the crisis and that initial turnaround, they spent years making significant investments. Leading up to 2024, they successfully built a global digital organization and the underlying infrastructure for a truly digitally enabled business. And this wasn't a quick fix. This was a fundamental retooling of the company's entire nervous system.
So what are these abstract systems doing in the background to make sure the physical bricks flow smoothly?
Well, you've got enterprise platforms tracking the entire life cycle, from the raw material to the retail shelf. This includes real-time tracking of supplier inputs for the ABS plastic pellets, rigorous production schedules that coordinate highly complex tooling demands, global distribution logistics, and critically, processing real-time demand signals from thousands of retailers worldwide. The whole supply chain planning solution is run by this platform. The coordination is entirely digital, even if the end product is completely tangible.
It's the ultimate paradox, isn't it? Lego's survival as a physical system depends entirely on abstract systems that most of us never see. The reliability of the brick is a function of the reliability of their software.
And that digital side isn't just about internal logistics anymore. It has become a massive, direct revenue driver and a crucial part of their external product experience.
Let's talk revenue then. The video games are not a side project. They are a significant pillar.
They are enormous. Cumulatively, Lego video games have generated over $1.7 billion in revenue. Titles based on major franchises, Star Wars, Marvel, Harry Potter, have sold more than 50 million copies. This revenue stream is predictable, it's high margin, and it leverages the investment they already make in licensed IP.
And we are now seeing the boundaries between the physical and digital worlds just dissolving entirely, most recently with their massive collaboration with Fortnite.
This is a textbook example of leveraging digital engagement to drive physical demand. The launch of Lego Fortnite late last year engaged an astonishing 87 million players by early 2024. But here's the crucial link. The digital platform is explicitly designed to drive physical sales. The engagement in the virtual world creates demand for the tangible product. The first physical Fortnite sets launched in 2024, directly capitalizing on that massive digital user base. The games, in this sense, serve as global, cost-effective marketing for the physical sets. It closes the loop.
And this digital expansion goes hand in hand with their other key strategic element, licensing, which is often framed as, a creative thing. But structurally, our source material emphasizes it as a powerful risk management tool.
That is the essential takeaway. In the highly volatile toy and entertainment market, licensed themes, like Star Wars, which alone has generated over $4 billion in cumulative revenue for LEGO, serve a vital function. They reduce demand uncertainty.
Right.
They provide narrative familiarity that instantly appeals to massive pre-existing fan bases, and they stabilize revenue in a way that original IP just struggles to match.
So if they launch a new set based on some niche original theme, the marketing challenge is immense. But if they launch a set based on a popular Marvel movie, the marketing is largely done for them.
Exactly. The franchise handles the heavy lifting of customer acquisition and brand awareness. And that predictability allows LEGO to manage production and inventory far more efficiently than they could with a completely untested internal concept. It reduces the exact inventory risk that helped cause the 2003 crisis.
But the licenses cost money, and they come at a cost to the consumer, too.
They do. Our sources indicate that licensed LEGO sets cost about 20% more than comparable original themes. It's a significant markup and is required to cover the royalty payments to partners like Disney and Warner Bros.
So why are consumers willing to pay that 20% premium? It seems counterintuitive to pay more for the same plastic just because it has a superhero logo on the box.
It comes down to segmentation. While, everyday parents might be price sensitive, there are two key segments that make this premium viable. First, the pre-existing fan bases, the Star Wars or Harry Potter collectors, are highly price insensitive.
Right.
They're buying a connection to a beloved universe, not just a toy. And this franchise loyalty lets LEGO maximize revenue per set. Second, the existence of a robust adult collecting market, which we'll discuss next, justifies the premium, because those collectors view the sets as display pieces and investments, not just transient toys.
By accepting licensed IP, though, they introduce a new set of constraints. External dependency. They gain predictability, but they lose some operational freedom.
That's the strategic trade-off. LEGO must now align its internal system with external dependencies. The strict release schedules of global blockbusters, the brand guidelines of Disney or Lucasfilm, the specific narrative constraints of the partner.
So if a studio delays a film,
LEGO's marketing and production schedules are immediately thrown into flux. And there's a risk concentration factor. If major agreements with partners who count for billions in revenue were suddenly terminated, LEGO would face a significant and immediate revenue hole. It's a carefully managed interdependence.
So we have this incredibly precise, reliable physical system built on immovable constraints. It's stabilized externally by licensing, internally by digital coordination, but that commitment to reliability across decades often makes internal innovation, especially in new business models, extremely difficult.
This is the classic paradox of a highly optimized incumbent organization. LEGO's entire internal culture, its system, is optimized for reliability, consistency, trust across generations. When you try to introduce radical change, particularly in something like software, the system that's designed to resist failure and maintain compatibility views that change not as an opportunity but as a threat.
So innovation has to fight to fit inside a structure that is designed to resist it.
Exactly. And the ultimate cautionary tale here is the spectacular failure of LEGO Universe.
Right, their ambitious, subscription-based MMO game.
They invested heavily in it, and the failure wasn't due to product quality. Test audiences loved it. They built a solid foundation, getting over 2 million active accounts. Yet it failed commercially. It couldn't generate enough subscription revenue to justify the massive operational costs, and they eventually had to shut it down.
And the internal source of that failure wasn't just market competition, but this culture clash. The clash between physical and digital development. How did that 0.00002% failure rate mindset clash with the rapid release culture of software?
It was a profound structural conflict. The physical brick business is characterized by these long development cycles, zero tolerance for error, extensive quality assurance before launch. The molds are just too expensive to get wrong. LEGO wanted to own every stage of the universe development internally. They brought the team in-house. But management tried to apply those same exacting rigid controls to the fast-moving iterative world of software.
So the physical system needs 6 years of planning and testing before a product ships, but a software product needs to ship in 6 months, iterate, break, and fix quickly.
Exactly. That rigid expectation of perfection just slowed development down drastically. They over-engineered the quality control, fearing digital failure the same way they fear a bad batch of physical bricks. This resulted in a system that was slow to adapt, and it couldn't match customer needs, especially once Minecraft hit the market in 2011 with a simple, flexible, and rapidly iterating platform.
So the better an organization is at managing a stable, consistent core business,
the harder it is to incubate a new, uncertain, and rapidly changing business model like an MMO.
That's a textbook lesson in governance failure, using the wrong metrics and cultural controls for a startup venture.
And it illustrates why, for so many companies trying these big digital shifts, external partnerships are often essential. It lets the incumbent leverage external agile expertise without forcing an immediate traumatic culture change that the system is optimized to resist. LEGO learned this lesson painfully before they got to their current digital systems and collaborations like Fortnite.
While digital innovation was a painful lesson, LEGO has seen immense success in expanding its audience beyond its original core demographic. They originally targeted ages 4–14, but the adult market is now absolutely vital to their growth strategy.
And this expansion is calculated and deliberate. It's marketed through campaigns like Adults Welcome. This isn't just a toy company anymore. It's selling intricate construction kits for display, for focus, for relaxation. They've successfully pushed into themes like the botanical collection, icons, architecture sets, all designed for display rather than rough play.
And what does this adult market contribute financially that the child market doesn't?
Significant stability and revenue maximization. Adult collectors purchase year-round, which helps stabilize cash flow outside of the holiday retail peaks. And crucially, they lead to transaction values that are 3 to 5 times higher than the average sale.
3 to 5 times.
Yeah. Sets from lines like architecture, icons, and botanical are priced significantly higher, anywhere from $40 up to $400 for highly detailed models. Expanding the market beyond that core child demographic has just unlocked explosive, stable growth in premium segments.
Finally, we need to address the inherent tensions within the product line itself, specifically the difference between sets marketed toward boys and those marketed toward girls. The sources highlight that even within a construction system, the narrative constraints imposed by marketing can subtly promote specific, sometimes stereotyped, gender roles.
This is a powerful insight from research analyzing the themes in messaging in 2 of their major segregated lines. Lego City, historically marketed to boys, and Lego Friends, marketed to girls.
So what were the findings on the messages being transmitted through the Lego City line?
The city sets overwhelmingly encourage boys to enact skilled professions, heroism, expertise, firefighters, police, rescue services. When these sets involved rescues or conflicts, the narratives were almost always described with a powerful sense of urgency and competence, using specific language like hurry, speed, and rush to emphasize immediate decisive action by skilled experts.
And how did that language and narrative contrast with the messaging in the Lego Friends sets?
The Friends line, which has these miniature doll figures in a fictional town called Heart Lake City, it encouraged girls to focus on hobbies, domesticity, caring for others, socializing, being amateurs, and striving for beauty.
Right.
Rescues in the Friends narratives often involve no immediate action. Instead, they focused on spending time with displaced animals at a shelter or on social activities like baking cupcakes, managing a horse farm, or staging a charity fashion show.
That distinction is incredibly striking. Urgent, skilled, decisive action versus care-based, social, non-urgent, amateur activities. It shows how the system, through its narrative overlay, can teach these subtle but persistent lessons about competence and priority based on gender.
It illustrates that the constraints on the system are not just physical, the precision of the brick, but they're also cultural, driven by these deep-seated marketing beliefs about how different demographics define play and what aspirational activities look like.
So this entire complex system, the precision, the backward compatibility, the long-term governance, the layered product portfolio, it's now facing its ultimate stress test.
The commitment to sustainability.
Right. And that binding constraint that every brick must work with every brick makes this goal immensely challenging, maybe the hardest engineering challenge the company has ever faced.
For Lego, sustainability is not primarily an issue of intent or marketing. It is a fundamental, non-negotiable materials science problem. Their engineers are battling the laws of physics and chemistry while simultaneously adhering to that 65-year-old compatibility mandate.
So why is this so much harder for Lego than, say, a company making sustainable packaging?
Because the core technical requirements for the brick are microscopic and non-negotiable. The replacement material can't just be green. It has to maintain extreme durability, resist UV degradation over decades, maintain clutch power perfectly across wide temperature swings.
All of that.
And crucially, obey those same microscopic tolerances, be 0.01 millimeter to 0.05 millimeter, as the current petroleum-based ABS plastic. If a new material fails on any one of those points, the entire system breaks.
So if they find a brilliant, sustainable plant-based plastic that's 99.9% similar, but it expands 0.02 millimeters more in normal summer heat, it immediately ruins backward compatibility and compromises decades of consumer trust.
It breaks the system.
They have to find a perfect functional substitute.
Precisely. And that's why progress has been necessarily slow despite massive investment. Lego committed to making sustainable bricks by 2030. They invested $150 million into R&D, hired dozens of scientists specifically for this task. They've been working on this for well over a decade, and the results, well, they reflect the monumental difficulty of the challenge.
And what does that progress look like today in measurable terms?
As of 2024, the status shows the challenge clearly. Only 3% of their total materials are what they classify as fully segregated sustainable materials.
Only 3%.
That's materials that meet all the technical and compatibility standards. This includes newly introduced elements, like transparent pieces, which now contain 20% artificial marble derived from, get this, kitchen worktop offcuts.
That is very specific. But that 3% figure seems almost negligible compared to the stated goal.
It really highlights the difficulty. However, they are also making progress upstream. They've managed to certify 47% of their resin purchases through what's called mass balance principles.
Could you quickly explain the difference between segregated sustainable material and mass balance for the listener?
Sure. Segregated material means the final brick itself contains a guaranteed percentage of sustainable material they can track, completely separate from fossil fuels. That's the 3%.
Okay.
Mass balance is different. It's an accounting mechanism where they buy raw material that is certified to contain an average of 33% renewable sources. So while not every single plastic pellet is 33% sustainable, they are removing an equivalent volume of virgin fossil fuels from the supply chain through their purchasing.
So it's an important step, but it doesn't solve the core engineering challenge of the brick itself.
Exactly. It's an important step for operational sustainability. It sounds like they're fighting a war on two fronts: the physical brick material, which is incredibly difficult, and the surrounding operational infrastructure.
That's exactly right. Beyond the brick itself, the group is heavily investing in operational sustainability. They're phasing out natural gas heating in Denmark, installing geothermal in Hungary, adding substantial solar energy capacity, an increase of 43% compared to last year. And water usage is another critical factor, especially in water-scarce regions.
Absolutely. Their factory in Monterrey, Mexico is in a high water scarcity risk location. So they focused heavily there, installing a new water treatment facility that saved over 85,000 cubic meters of fresh water in 2024 alone. It shows a systemic approach to risk management across their whole infrastructure.
And finally, we see the shift in packaging, which I guess is the least constrained element of their system.
Exactly. Since the packaging doesn't have to fit with decades of existing products, the progress here is much faster. They are aggressively reducing single-use plastic, introducing paper-based bags for elements inside the sets. They expect to complete the full transition to paper-based packaging by 2027. It just shows that where the binding constraint is absent, innovation and change can happen much more quickly.
So when we started this deep dive, we set out to look at Lego not as a collection of brightly colored plastic bricks, but as a system. And reviewing everything we've covered, the microscopic tolerances, the complexity from strategic layering, the near total collapse, the governance structure, that central idea really holds true. When you strip away the nostalgia and the branding, Lego looks far less like a toy company and far more like a meticulously engineered infrastructure for play.
And infrastructures, by their very nature, they don't move quickly. They move carefully. The immense success of the last 2 decades was achieved by protecting continuity. That is, the precision, the backward compatibility, the multi-generational family governance, rather than maximizing short-term freedom or rushing disruptive innovations.
Which they learned the hard way with Lego Universe.
They painfully learned that lesson. They became the largest toy company in the world by embracing those binding constraints and making the system work within them.
It's a powerful lesson in strategic patience and the long-term cost of quality. But it does lead us to one final open question for you to consider as we wrap up.
The open question isn't whether Lego can eventually find sustainable materials or continue to develop lucrative new digital products. They're clearly dedicating massive resources to both. The real fundamental question is whether the core binding constraint of every brick must work with every brick, which is the source of their generational trust, their market dominance, their structural integrity, will eventually become the ultimate immovable barrier to their ability to survive the next 60 years of technological complexity and climate change.
Will the single greatest strength they possess become the one constraint they simply cannot innovate past?